Hey guys, Mr. Milton here. Today we're looking at solving quadratics using square roots. At the end of this video, you should be able to determine when it is appropriate to use square roots to solve quadratics and when it's not. And you should be able to solve a quadratic using square roots. At the end of the last lesson, I explained why solving quadratics by graphing isn't always ideal. Today, we are going to look at the set of 5 methods for solving a quadratic. This method is the fastest, but can only be used in certain situations, so it gets not used as much because you can't use it all the time. So it says use the following or solve the following quadratic by graphing. So remember, with graphing, we had to find our axis of symmetry, which is x equals opposite b over 2a. In this case, b is 0, so 0 over 6 is 0. So x equals 0, we found our axis of symmetry to be here. Okay, then from there we found our vertex by plugging 0 into our function, and then that was 3 times our y equals 3 times 0 squared minus 3, which is 0 minus 3, which is negative 3. 1, 2, 3. So we found our vertex. From there we would make a table. X, y. In the middle of our table we put 0, negative 3, and then choose values around it. 1, 2, negative 1, negative 2, and then we plug those points in. So 3 times 1 squared minus 3, which is 3 minus 3, which is 0. There we go. So when x was 1, y is 0. When x was 2, 412 minus 3 is 9. Y was 9, 0, 9, because of symmetry, we know that's the same. So we have 1, 0. We got 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, all right. And we're really focused on solving it anyway, so we should recognize the solutions happening. Oops. As we see them here. Okay. And so our solutions, remember, happen where our graphs cross the x-axis, and that's there. Okay, what are our solutions? Our solutions are 1 and negative 1. Okay, now I'll show you another way to get to the same answers, but hopefully much quicker. First, we're going to solve this like an equation. We're going to try to get x by itself. Let's 3x squared by itself first, I guess. Okay, so we're going to add 3 to both sides. So we're left with 3x squared equals 3. Then we divide both sides by 3. And we get x squared equals 1. But how do we get x by itself? We have to square root both sides. When doing that, you should get x equals 1. So how do we get the other answer? The negative 1, right? Because if we just take the square root of size. When you take the square root of x squared, you are asking what number times itself equals 1? Well, we know 1 works, but doesn't negative 1 also work? We need to include both numbers that work. So we say plus or minus 1. So for this answer, we say x equals plus or minus 1. That's our way of saying negative 1 and positive 1. Okay, this is a recurring theme in this unit. When you take the square root of something, you have to remember both the positive and negative square roots. Okay, so let's solve these problems. All right, we have 2x squared minus 98 equals 0. So we're going to get the x squared by itself. At 98. Okay, to both sides. 2x squared equals 98. Divide by 2. X squared equals 49. Take the square root. Okay, square root of 49 is 7. remember that as you write this, you want to make sure that you include that there's a positive 7 because 7 times 7 is 49, but also negative 7 because negative 7 times negative 7 is 49. Number 2, 3x squared plus 4 equals 31. Our first step is going to be to subtract 4 from both sides. 3x squared equals 27. Divide both sides by 3. X squared equals 9. Then take the square root. X equals plus or minus 3. Number 4. Oh, nope, number 3. Subtract 32. So 2x squared equals negative 32. Divide by 2. We get x squared equals negative 16. If you try to take the square root of this, your calculator should say domain error or something of the sort. Okay, because remember, you cannot take the square root of a negative number. So once we get here that we're taking the square root of a negative number, we say no solution. And actually no real solutions, because in Algebra 2, you'll find out that there are imaginary solutions, but we won't worry about that here. Okay, we'll just say no solutions. That'll be okay for our causes. So number 4, we have 4x squared plus 25 equals 25. Subtract 25 from both sides, get the 4x squared by itself. That gives us 0. Divide by 4, get x squared equals 0. Take the square root of 0, your calculator can do that. Okay, it can. So square root of 0 is 0. Okay, notice you don't have to say plus or minus 0 because 0 is neither positive nor negative. So you just say x equals 0, and that works out. What would happen if I were to graph each of these instead of using square roots? In number 1, that parabola would cross the x-axis at negative 7 and 7. On number 2, that will cross the x-axis at 3 and negative 3. On number 3, that would never cross the x-axis. Okay, that's why there's no solutions. And on number 4, it would touch the x-axis at 0. Okay, and that's why those solutions are there. Okay, so our solutions that we find by graphing are going to be the same solutions that we find by solving with square roots. Okay, let's look at a couple more examples here, kind of pushing our square rooting limits a little bit. Okay, we can solve these. We want an exact answer. Okay, so we should, if we have to leave our answer in simplest radical form, leave it in simplest radical form. If not, and we have to use fractions, then we use fractions, okay? We do not need to use decimals here. Okay, so we have 9x squared minus 64 equals 0. Let's solve for x. Our first step is going to be to add 64 to both sides. And so we get 9x squared equals 64. Divide by 9 on both sides. And we get x squared equals 64 over 9. Which might seem unsettling a little bit, but it's okay. Now we need to solve it. We can solve by taking the square root. Remember, we've already square root. We did a whole unit on this, right? So square root of 64 over square root of 9. These are both perfect squares. So you might say, okay, x equals 8 over 3. But don't forget that we need to make sure we include our positive and negative root, because 8 over 3 times 8 over 3 does equal 64 over 9, but also negative 8 over negative, or 3, sorry, yeah, negative 8 over 3 times negative 8 over 3 equals 64 over 9. There we go, said it right. All right. Number 2, solving for x in this situation. Our first step is going to be to add 8 to both sides. So we have 1/3 x equals 28. And then to get x all the way by itself, we'll multiply both sides by 3. All right, that's how we inverse operate, get rid of 1/3, right? And so when we do that, we get x equals 84. Or sorry, x squared equals 84. To get x all the way by itself, we take the square root of both sides. And so when we take the square root of 84, it's not a perfect square. So as we look through, like, hey, how can we break this down? This is like 3 goes in there, 28 and 3. Okay, 3's prime, 7 and 4, 7's prime, 2 and 2. So we have a pair of 2's and a 7 and 3 without a pair. So the 2's go on the outside, 7 and 3 without a pair go on the inside, and multiply. Okay, so again, this is typically what happens. People simplify radicals and then they forget about everything else. Okay, but our answer is going to be x equals plus or minus 2 radical 21. So you have to take the positive and the negative root. It is true of fractions. It is true of radicals. Whenever we take the square root, we have to make sure that we're including the positive and the negative. Okay. I mentioned at the beginning of the notes that to use square roots, certain things have to be true. Why would square roots not work for x squared plus 6x minus 16? Here's why. As you try it, you're trying to get x squared by itself, and so you probably subtract 6x from both sides and add 16 to both sides, and you end up with x squared equals negative 6x plus 16. And then you try to take the square root, but can we take the square root of negative 16 plus 6x? No, can't. So in order to use square roots to solve a quadratic, the b value must equal 0. Anytime we have a b value that's visible, not equal 0, we're going to need a different method. And that's what we'll look at next time. All right, so that is solving using square roots. Hopefully you see how that matches and intertwines with graphing. And we'll look at other methods as we go. See ya.